Chapter 1 Introduction. Basically, there are 4 topics that will be covered in this chapter. First, introduction. Second, basic terminology and concepts. Third, solutions of differential equations. And fourth, inertial value problems. At the end of this lesson, you should be able to define differential equations and classify them according to their type, order, and linearity. Differential equations often occur in diverse fields of studies such as physical sciences, social sciences, engineering, and medicine. They arise as mathematical models to represent problems of phenomena involving the relation and change in the variables of interest. Some examples of these phenomena are the behavior of a falling object, growth of a population, the tidal wave, carbon dating, heat transfer, and the spread of a disease. Basic terminology and concepts. The first equation is an example of an algebraic equation. It contains y as a variable that represents an unknown number. What is the solutions for this equation? Yes, the solutions are y equals to 1 or y equals to -4. The second equation is an illustration of a differential equation. It is expressed in terms of the variable y and its derivatives with respect to another variable x. Unlike the algebraic equation, the variable y in the differential equation is a function, and the solutions for the given differential equation are in the form of functions y equals to e to the power of x or y equals to e to the power of -4x. Definition of a differential equation. A differential equation is an equation containing the derivatives of one or more dependent variables with respect to one or more independent variables. Look at the given example. The dependent variable for the equation is y and the independent variable is x. The number 4 and -3 are the coefficients. Look at another example. What is the dependent variable and independent variable for the given equation? Notations for derivatives. Table 1 shows the forms written for the derivatives in terms of the Leibniz and prime notations. Note that for the fourth or higher order derivatives, the primes are replaced by a number written in the parentheses to represent the order of the derivative. Types of differential equations. There are 2 types of differential equations. The first is known as the ordinary differential equations or ODE, and the second is the partial differential equation or PDE. ODE contains ordinary derivatives of one or more dependent variables with respect to a single independent variable. PDE contains the partial derivatives of one or more dependent variables with respect to two or more independent variables. In this course, we will only concentrate on ODE. Order and degree of differential equations. The order of a differential equation is the order of the highest derivative that appears in the equation. The degree of a differential equation is the power of the highest derivative that appears in the equation. Look at the given example. For the first equation, the order and degree is 1. For the second equation, the order is 3 and the degree is 1. For the third equation, the order is 2 and the degree is 3. And for the last equation, the order is 5 and the degree is 1. Linearity of a differential equation. A differential equation containing y as the dependent variables and x as the independent variable is said to be linear if all the following conditions are satisfied. First, the powers of y and its derivatives are all equal to 1. Second, there does not exist any nonlinear functions of y in the equation, such as y squared, y to the power of negative 1, log of y, exponent of 3 of y, and cos of 2y. And third, there does not exist any products of y and its derivative, or products of a derivative with another derivative. Here are some examples of linear differential equations. And here are some examples of nonlinear equations. The first equation is nonlinear because the power of the second derivative is not 1. The second equation is nonlinear because it involves the product of y and y prime. And the third equation is nonlinear because it contains a nonlinear function, log of y. Try this quick check exercise. Write your answer in the comment section. Thank you.